Hi, in this video we introduce conditional statements. Up to now our scripts have been such that all the statements get executed in sequential order. That means one after the other as they are written. However, most programs require some sort of decision making. In other words, yes, sequential order is the default mode of execution, but often programs come to a point where a decision has to be made. This decision is based on some condition. So for example, this condition could be a test in which the program verifies or checks if a variable, let's say, is above some value, let's say above 50. So if x has a value greater than 50, the program should do this and otherwise do something else. So let's start with the basic if statement. So what does an if statement do? Well, it allows the program to check a given condition. So the program, let's say, comes along. So this is called a flowchart. And so you have statements here, and the program is executing them one after the other, and then it meets this condition and it tests it. If this condition turns out to be true, for example, x is greater than 50, then program branches and comes along this path, executing the statements one after the other. So sequential order is the default, and then of course returns. And then you have more statements here. So the program comes along. If it's true, these statements get executed. If it's false, the program simply continues. Notice that any statements that are here get executed whether or not the condition is true or false. So notice if it's false, it comes along and executes these statements. If it's true, it comes along, execute these statements, and then simply follows along here. So there are no statements in this case that get executed only if the condition is false, and we'll address that shortly. So here's a little example. This code will ask for an integer. If the integer is even, the program will point out that it is even. So how do we check for how do we check if a number is even? Well, we simply divide it by 2 and check that the remainder is 0. So the program starts with this input, please enter an integer, and of course we have this here to convert it to an integer. So remember, this is called typecasting. Then I have a little print statement here just to put some space. Now the program will have gotten that number and placed it in this variable, and then it checks. Remember, so this is called the modulus, and what it does is it gives you the remainder of a division. So that number would be divided by 2 and produce a certain remainder. If the remainder is 0, then yes, it's an even number, and then if not, well, nothing gets done, and the statement simply follows. Notice we can't put out here something like yes, it's an odd number, because even if the number is even, these statements get executed, these two here, because it follows the if statement. So these statements here are like statements placed here. They get executed whether or not the condition is true or false. There are no statements here that get executed only if the condition is false. So let's run this little piece of code here. So if I run that, and let's say I enter 7. Thanks for participating. Let's run it again. So notice this code gets executed. This doesn't, because the number is not even. So this code will only get executed if this condition here. So this is often called a predicate. So if this predicate evaluates to true, then and only then will this code be executed. This gets executed all the time. So let's run this again. And let's put it. Oh, an even number. Thanks for participating. So what I want you to do here is write a small script that prompts the user for an integer and then prints an output only if the integer input is odd. So basically that's writing this over and checking that this is equal to 1. If it's equal to 1, then it's an odd number. So make sure you do this. Now we have the if-else statement. So with this type of conditional, you have statements that are executed only if the condition is true, and now you have statements that are executed only if the condition is false. So note, both of these statements can't be executed. If these statements are executed, then these are not. If these statements are executed, then these are not. A condition cannot be both true and false, so it has to be one of these, can't be both. Of course, the program then continues here. So there are statements here that follow. So in this example, we follow the same idea. We're going to ask for an integer, and if the integer is even, the program will point that out, and if it's odd, the program will also indicate that. So notice now we once again get the number, we check if it's even, and we print wow, an even number, and then we have else. So this is the syntax. You go if, and you put the condition here, and then what happens if the condition is true, and then you have an else, and everything that goes in this block, in both of these blocks you can have more than one statement. So and the system will know that it goes in this branch over here. It'll know that it's stuff that's to be executed if the condition is false, as long as the code you write has the same level of indentation. So remember, indentation is very important in Python. So we come along, program checks this condition. If it's true, this gets done. Otherwise, this gets done. So note, both of these can't get done when this program runs, either this one or this one. Now these two statements get executed all the time, regardless of whether this was true or false. So let's run that. So let's enter 8. Wow, an even number. And notice this prints a blank line here, and this gets executed. Now let's run it again and enter the number 9. When I do so, this won't execute, this will execute, and of course these two statements will also be executed. So let me run that. Place 9, and notice we get psi, an odd number. Thanks, I guess. And this statement gets executed, and then this statement gets executed. So here you have a little task. Write a script that asks the user to enter the current temperature. If the temperature is above a certain value, the program should tell the user to dress a certain way. Otherwise, the program should indicate that some other clothes are appropriate. So if you look at this, you'd follow the same pattern. You'd get a number from the user, but now you check if the number is greater than some value. So don't use this modulo sign, use the greater than sign. Let's say you decide that you're going to decide that it's hot if the number is greater than, let's say, 85. So then you print here, you put in here first number greater than 85, and then you put here dress slightly or something. And then in the else here you put you should wear heavy clothing because it's cold. So do that here. Now the if-elif statement. Sometimes if a condition is false, you want to then test another condition. Well, you can just simply put an if statement in here and do that. But putting an if statement in here introduces another level of indentation, because then what you do if evaluates true would now have to go at a third level of indentation. Notice you have an if statement. If it's true, what gets done is that the next level of indentation. So if I start off putting an if here, so let me just write if like this. If I write if there, if let's say num greater than, let's say equal, so if it's false, I want to know if it's equal to, let's say 7, and then I write here. Notice it's at a third level of indentation. And of course now if this turns out to be false, maybe I want another if statement, and so the levels of indentation can increase, and it can make the program hard to read. So instead of doing this, it is recommended that you use the elif statement. Notice we were going else and then doing another if. Well, elif combines the two. Elif means else if. So this is the flowchart. You have a condition, let's say x less than y. So these are two variables that have been defined previously up here somewhere in the program, and the program is now checking if it's less than false. If x is less than y, do these statements. And then notice if it's less than y, it doesn't necessarily mean that it's greater than y. It could also be equal. So now we check, is it greater than y? And if it's greater than y, we do these statements. And then only if it's neither greater than y nor less than y, do these statements get executed. And of course then out here the program continues as normal. I would not recommend ever using else and then another if. If you want to check again, simply use elif. So here's an example. In this program, we check if the number is positive or negative or 0. So that's basically the same idea here. The number is 3.4. And you should try other variations. You should try, say, number equals 0, number equals negative 4.5. You could also adapt this program and use an input statement so you don't have to be writing it over and over here. So notice the logic of the program. If the number is greater than 0, just print positive number. Elif, so notice now this is another conditional. If it's equal to 0, so this is really saying else if it's equal to 0, do this. And you can have many elif statements and they would all be at the same level of indentation, which makes the program a lot easier to read. You have your first if and then you have another if, and these ifs here, these elifs, are executed only if the previous is false. So if this is false, then we check this elif. If this is true, then we're done and the program continues out here. So then we'd have other statements out here and the program would simply continue. So if this condition is false, then we check again. And if this one is false, we could check again if we wanted to, although that would not make any sense in this context. And then finally, if everything is false, if this is false and this is false, then we simply have something, we don't check anymore, we just simply print it's a negative number. Notice we could have checked here, instead of equals 0, we could have checked less than 0 and then printed negative number here. And then here simply print else, false, and 0, sorry. So in this case, notice if it's neither positive nor 0, it has to be negative. If we had checked for negativity here, if we had said elif number less than 0 and printed print negative number, then if it's neither positive nor negative, it would have to be 0. So let's run this. And we have positive number. So we came here. Let's change this now to negative 5. And we get negative number. And if we change this to 0, we get 0. So notice 3 of these statements can never be printed. This can only be printed if this condition is true. This can only be printed if this condition is false and that this condition is true. Alright, so here's a task. Write a script that asks the user to enter an integer, so you know to use input, and the program should output an A if the number is greater than 90, B if between 80 and 90, C if between 70 and 80, D if between 60 and 70, and this should be F. So that should be an F. So I apologize for that. First thing you do here is check if the number is greater than 90, and then you print a elif, and then you just check that it's greater than 80. You don't actually have to check that it's between 80 and 90, because the only way you get here is if the first statement is false. So if it's not greater than 90, and then you come here, you simply have to check that it's greater than 80. And then you do another elif and check if it's greater than 70, another one to check if it's greater than 60, and then finally an else, and you print F. So think about it. I don't want to do this for you. So if we end on this note that these statements can be nested, and so you can have very complex programs. The idea isn't to make your life miserable and give you very, very hard things to program. I just want you to have the idea. You should be aware, however, that this can get a bit complicated. So here your program can come along and check if this condition is true or false. If it's true, for example, if x is less than y, then you can come here. So this statement gets executed once x is less than y. Now if x is not less than y, we can come here and check, if it's greater than y. If it's greater than y, then this gets executed. And of course this gets executed if this is false. So of course then this becomes this means that this gets executed only if x is equal to y. So I hope you can see that. So if it's false, we have another test. But here if it's false, we don't have another test. So this is like an else statement. So you have an if, and then you have an elif, and then you have an else. And then you're done. So draw the corresponding flowchart for this. So a statement gets done. So you have a statement somewhere up here. And then you have a condition. If the condition is true, we have another test. So here's just an example so that you can practice reading code. Um, for the most part, people would not write code like this. They would use an elif instead. But I just wrote this at it so that you are aware that sometimes you do find code like this. So make sure you understand. I would recommend that you rewrite this code using an elif, which would then bring this to the same level of indentation as this if. Alright, so that's it for this little video here. I hope I have been clear enough. Thanks for watching.